Hello and welcome back to Everything Boats with Captain Frank Lanier, where we discuss boats and boating, from maintenance and repairs to seamanship and safety, as well as everything in between. This podcast is a companion to my YouTube channel of the same name, so if you like and find it useful, be sure to subscribe and please check out my YouTube channel as well, where you'll find hundreds of informative videos on pretty much every boating topic imaginable. So today we're going to be talking about 5 common boating situations. 5 common boating situations that every boater should be prepared to handle. So let's get right into it. First up, situation number 1, replacing an alternator belt. While that squeal coming from your engine compartment may sound like a scene from Deliverance, it's more likely your engine's way of saying that the alternator belt needs to be replaced. A belt that's beginning to disintegrate will show signs of fraying or cracking, which can usually be seen while in place with a flashlight or a hand mirror. The presence of belt dust is a black dust or residue on the front of the engine. That's also a common sign of belt deterioration. It's also a possible indication of wear due to misalignment issues. So if you sight belt dust during your inspection, you should always use a straight edge to verify that the pulleys and the idlers and stuff are square. When installing a new belt, start by studying the old belt's routing if intact and still in place. Simplify things even more by taking a few pictures for reference prior to removal. If the old belt is self-destructed, verify the routing of the new belt by consulting your engine manual. Removal of an existing belt or replacing a broken one would typically involve loosening some components, such as the alternator or possibly an idler pulley, and then retension and then tighten it after the new belt is in place. Once installed, use your thumb to apply moderate pressure halfway between the pulleys. The new belt should deflect about 3/8 of an inch, depending on the length of belt between the pulleys. Be sure to follow your engine manual for specific guidelines. Situation 2, electronics failure. What's the plan if your depth sounder blanks out while entering a questionable harbor or the chart plotter bites the dust when heading out for a day of fishing? The first step in troubleshooting a piece of electronics gear or system is something you've hopefully done before the problem even arises, and that is reading the owner's manual. A basic understanding of how a system functions and how it's installed, a block diagram, for example, before you start troubleshooting is extremely helpful in recognizing and locating common problems. Most manuals will have a basic troubleshooting section, which can help point you in the right direction. When a piece of electronics gear fails to turn on, start by checking the power connection at the unit for looseness or corrosion. If your DC power panel has a voltmeter installed, take a quick look to verify that it shows the correct voltage and that all required breakers are in the on position. For electronics that work intermittently or lose certain functions, check the remaining plugs or wire connections. These could also suffer from corrosion or may have loosened over time due to vibration. As odd as it may sound, sometimes problems can be corrected by simply disconnecting the cable plugs and plugging them back in. Same is true for inline cable connections, which can become loose due to excessive movement or vibration if not secured properly. Trace the cable run as well while looking for breaks or other damage. If a piece of electronics powers up but shows nothing on the display, start with the simple stuff and check the display brightness and contrast setting. Other control features can also generate what I like to call operator-induced anomalies. If your radar fails to pick up targets, for example, verify that you're on the correct range setting and that the gain and sensitivity features are properly adjusted. When it comes to no power issues, if you've verified all the connections are tight and free from corrosion, but the problem still exists, now it's time to get all technical and break out your multimeter. Every boat should have one on board, particularly as basic units can be purchased for less than $10. Stay away from light pin type voltage testers, however. They can tell you if there's voltage present, but not how much, a critical troubleshooting flaw, as many electronics fail to operate if the voltage drops below a certain level. To check the power to a piece of gear, turn the unit off, disconnect the power plug, or access the terminal strip where power is connected. Then verify that the battery switch and breakers are in the on position. Set the multimeter to the appropriate DC voltage setting, typically 12 volts DC, but you'll need to verify this with whatever meter you have. Many of the higher quality digital meters will auto scale to the correct voltage, eliminating this step. Next, measure the voltage by connecting the meter's negative probe to the equipment plug, negative lead, and positive probe to the positive lead. If you accidentally reverse the probes, the worst thing will happen is a digital meter will simply display a negative reading. A voltage reading of 0 indicates no power is reaching the unit. Common causes include a trip breaker, blown fuse, loose connection, or a broken wire. One thing to note is that if a fuse blows multiple times when replaced, that fuse blowing a multiple time, that should be considered a symptom rather than a problem itself. That fuse is blown because there's something else wrong. The problem is not, hey, my fuse is blown, right? Particularly if it does it multiple times. A low voltage reading indicates low battery voltage or possibly additional resistance in the line, such as a corroded or faulty connection. Verify that the correct amount of power is leaving the breaker panel, then work your way towards the equipment in efforts to identify the problem. If the voltage shown at the meter is incorrect, then verify that the voltage at the battery is correct and proceed from there. In other words, you may have a low voltage, situation at your breaker panel, and then you check your battery and the connections are corroded or something, and that's preventing the voltage from getting to your panel. Another fact to consider is how steady or constant the voltage is during equipment operation. Some electronics draw more power during certain operations. A perfect example of this is your VHF radio when transmitting versus receiving. While you may have a full 12 volts at the power plug when the radio is disconnected or simply turned on and receiving, that voltage can drop well below a usable level when the radio is keyed to transmit. So you would check your voltage, normal operation, receiving, then you key the mic and see if it drops below a usable level. This is often due to a weak battery or possibly a corroded connection. If your system has a DC voltmeter, monitor that voltmeter or use your digital voltmeter while keying the radio to see if the voltage drops. Situation number 3, bleeding a diesel fuel system. Changing a primary fuel filter often introduces air into your fuel system. This air will typically have to be removed or bled from the system to prevent air from blocking the flow of fuel to the engine. Air removal involves sequentially bleeding the fuel system at specific points. Your owner's manual will outline the procedure for your particular engine, but here are a few general steps that should work for most any engine. Number 1, locate the engine lift pump and manual lever. Loosen the bleed screw on top of the secondary filter. That's the smaller filter normally attached to the engine while operating the pump. You only need to loosen the screw slightly, not remove it. Place a container beneath the filter beforehand to catch any spilled fuel. Continue pumping this little manual fuel pump until all the bubbles are gone and only clear fuel weeps from the hole. And then tighten the screw before you stop pumping. In other words, you're going to be pumping the air out. You'll start getting a solid stream of fuel. Then you tighten the bleed filter before you stop pumping. Repeat the pumping procedure, only this time loosen the bleed screw or fuel line fitting if no bleed screw is present. At the injector fuel pump, a half a turn. Then tighten as soon as clear fuel is ejected. Same thing. You're going to start pumping with that little finger fuel pump on your secondary filter, and you're going to keep pumping until you get clear fuel, no bubbles, no air bubbles, and then you keep pumping as you tighten this thing back down. Next up, locate the closest injector to the injector pump. In other words, the one with the shortest fuel line. Loosen the injector fuel fitting slightly and continue pumping until clear bubble-free diesel runs out, and then tighten it. Repeat this process for all the remaining injectors. Again, this is a basic generic overview of how to bleed a diesel. You want to make sure that you look at your specific engine, the manual for it, to see if they have specific steps for you to do when you bleed the engine. Once you've got the air bled out of the system, try cranking the engine. If it fails to start after about 10 seconds or so, go back and check to make sure everything is properly tightened. And then you can try it again. Here's one good tip I'll give you before you have to start bleeding your engine. Identify bleed nuts beforehand and paint them with white nail polish to make them easier to locate. Marking the appropriate sized wrench that you're going to use to bleed these things with a dab of white paint will make identifying them easier as well. So all you have to do is, you see the nail polish marked places to do it. Then you've got your wrench, got a little dab of white paint on it, and it just makes it quicker to go through, identify them, and get started. Situation number 4, dealing with a clogged head, right? With the possible exception of where's all this water coming from, nothing strikes fear into a boat owner's heart quite like, the toilet isn't working for some reason, particularly when you consider that this issue normally makes itself known after the deed is done, right? The inability to pump the bowl clear is one of the most common marine toilet problems, and it almost always involves a clog or a blockage. Somebody flushed something the system couldn't tolerate. No one ever fesses up, by the way. And here we are, an unpleasant situation with even more unpleasant prospective solution. For our purposes, we're going to assume the toilet is a manual raw water flush unit.
the system most commonly found aboard small to mid-sized boats. Many sanitation systems will have a Y selector valve, which allows you to discharge bowl contents either directly overboard or into a holding tank. Check to make sure this Y valve is fully open. Perhaps even work it a few cycles, open and close it to verify proper operation. If you are discharging overboard at sea or in an area where it's legal to do so, verify that the overboard discharge seacock is also in the open position. If you're in a legal overboard discharge area and pumping into your holding tank when the problem occurs, you can also shift your Y valve, open up the overboard discharge seacock, and then see if the system works. If so, you've just verified that everything from the toilet to the overboard through hole discharge is operational and that the problem lies between the Y valve and the holding tank. If you're discharging into a holding tank, a more likely scenario, and are still unable to empty the bowl, make sure that the holding tank is not full and that the holding tank vent isn't clogged or blocked. Insects like to build nests in the vent hose if the screen for the hull vent is missing. I've also seen vent hoses clogged with bits of toilet paper or waste, which will again prevent you from being able to pump into the system because the air has no way to escape as you're putting effluent into the holding tank. If the above items check out, yet the toilet handle is difficult to press down and you cannot empty the bowl, chances are you have a blockage in the discharge hose. You can try blasting the clog free by using a household plunger. Just keep in mind it will only work in one direction, the downstroke, right? Due to the one-way valve or flapper, also called a joker valve, right? Installed at the toilet discharge to prevent waste from backflowing into the bowl. If the plunger method fails, then it's time to gird your loins and get dirty. Rubber gloves, old clothes or coveralls, and a stout length of wire, a fish tape or untwisted coat hanger, and a 5-gallon bucket are the recommended weapons you're going to need to tackle this. Start by disconnecting the hose at the toilet discharge outlet and running the wire down the hose. If you're lucky, the clog will be found and you can break it free. Otherwise, it'll be trench warfare from here on out as you disconnect each successive length of hose until the blockage is located and removed. I'll give you a tip too. If you're removing these hoses and the hoses are old, I'd go ahead and replace them if you can. If you replace each section of old hose with new hose, it's a good preventative measure against permeation and odor issues because these older hoses will start smelling. They'll permeate, the waste will permeate through them, and then they can introduce smell into the head. Situation number 5, change an engine raw water pump impeller. The best way to avoid collateral repercussions of impeller failure, overheating, or the need to disassemble the entire engine cooling system to retrieve impeller bits and pieces is routine inspection and impeller replacement before failure. Many boaters simply replace the impeller during their annual inspection or when they winterize it, in the fall, right? Regardless of how it looks. It's cheap insurance, and you can always keep the ones that are in good condition on board as emergency spares. While you want to follow the instructions provided in your engine's owner's manual, here are a few basic steps for replacing an impeller. Step 1, close the engine raw water seacock. Number 2, place a shallow bowl or spread an old towel beneath the pump to catch any wayward parts that fall out. Number 3, remove the screws that hold the pump's cover plate on. And number 4, carefully remove the cover plate to expose the impeller. If the cover is stuck, gently pry it free, being careful not to bend or damage it. Inspect the cover for distortions, scoring, or other issues, and make a note to replace it as soon as possible if you find any issues with it. Step 5, remove the sealing O-ring or paper gasket. What you're going to have is dependent on the pump make and model. O-rings or gaskets in good shape could be reused in a pinch, but replacement is often the best policy, right? You already got this thing disassembled. Why not just put new gaskets or a new, O-ring in there? Yeah. If the impeller has a rubber plug in the center, pry it out with a small screwdriver to see if the impeller is attached to the shaft. Many just slide right on, although in some cases they may use a through bolt or a set screw, which will then have to be released prior to removing the impeller. To remove the impeller, grasp 2 of the impeller vanes on opposite sides using your thumb and forefinger and pull it or wiggle it out, work it out. If that doesn't work, try working it out using 2 flathead screwdrivers placed on opposite sides of the impeller, being extremely careful not to damage the flat face of the pump housing. A pair of impeller removal tools constructed of plastic to avoid scratching the pump housing while prying the impeller out is also a good investment. Another option is using channel lock pliers to grip the impeller hub and wiggling it free. Grease the vanes of the new impeller and the wall of the pump chamber. Most impeller kits will include a small tube of lube The petroleum jelly will also work. Slide the impeller onto the shaft. Folding the vanes while inserting it with a slight twisting motion may make this easier. Installing the vanes in the proper direction is best. However, they will rearrange themselves with the first revolution of the impeller regardless. Push the impeller firmly into place. Then, if present, tighten the set screw or reinstall the through bolt or hub plug. Install the gasket or O-ring as per the impeller instructions and screw the cover back into place. Finally, open the seacock, then start the engine and check the exhaust for proper water flow. Check the pump and verify no leaks are present also. So now I've got some good tips, overall general tips on repairs underway. But first, if you like this video, please like, subscribe, and share with all your friends and all the people you hate too. So let's talk about tech support. It's always a good idea to keep technical support numbers handy for all your onboard systems. Many boat owners or captains have them stored in their cell phone or sat phone for instant use. Before making the call, make sure you can describe the symptoms of the problem and what troubleshooting steps you've already taken. This is going to be crucial. It'll help the guy on the other end of the line, help you troubleshoot what the problem is. If you can accurately describe what the problem is, and you can tell them what troubleshooting steps you've taken, now they have something to work with. It's also a good idea to have all equipment or system information on hand, such as model, serial number, and such, before you make that call to tech support. Finally, some basic repair rules. 1, be prepared and carry the proper tools, manuals, and parts. Number 2, always check the simplest things first. Number 3, take your time. Number 4, always troubleshoot your problem logically and methodically. Number 5, if you take something apart, stay organized. Take plenty of photos, videos, mark larger items, and store small parts in marked Ziploc style bags for easy reference. Number 6, don't be afraid to tackle a repair or ask for help when needed. Number 7, electrical problems typically boil down to something that's loose, wet, or has a dirty connection. And finally, number 8, if something fails after completion of a repair or maintenance procedure, then that's the first place you start looking for. If you're doing a routine maintenance item and you fire everything back up and something's going wrong, well, that's the first place you're going to start your troubleshooting at. You did something, now it's not working. Let's start at that, location or that area and see if there's something we forgot to do or left disconnected or whatever.
I hope you enjoyed today's podcast. And if so, and you want to buy Captain Frank a cup of coffee, please click on the support link in the text description below. All monies received, not spent on coffee, will go towards making even more awesome podcasts for my channel. And as always, thank you for your support.